Okay, so now let's do an example of an application type problem involving work. So here we've got two pipes that are filling a basin, right? Some basin or some container of some sort, right? So we've got pipe 1 and pipe 2. So let me read what the setup is and we'll go from there. It says pipe 1 fills a tank in 6 minutes, right? So we know pipe 1, so let's do this, pipe 1, it can fill the tank in 6 minutes. Okay, pipe 2 fills the same tank in 8 minutes. Okay, so let's see here. Okay, so there's first two pieces of information to give us. Now, it says, how long does it take for both pipes together to fill the tank? All right. How long is it going to take both pipes if we turned them on at the same time with an empty tank? How long would it take both of them to fill the tank? So this is classic work rate problem. Okay, so what do we know? Well, what's the rate? They give us the rate, right? Well, or we can easily find the rate because it can fill one tank in 6 minutes. So its rate, I'll call it rate 1, is 1/6 of the tank per minute. Right? And based on this information, rate 2 is going to be, it fills a tank in 8 minutes. So its rate is 1/8 of the tank per minute. Because after 8 minutes, right, 8 times 1/8 is 1. You'll have one whole tank filled. Okay, so we got R1, R2. Now the thing is together, how long will it take to fill the same tank? Well, in this case, let's set up the problem, see how this works. So again, setting up the formula, we got R1 times T1 plus R2 times T2 has to equal one whole tank, right? So again, W1, the amount of work done by the first pipe, plus W2, the work done by the second pipe, meaning how much of the tank is filled, right, has to equal 1, right? One whole tank. They're working together. Now, we know the rates. Okay? Now, the amount of time though, now here's where we can use something to our advantage. They're working at the same time, right? We turn the faucets on for both of them at the same time. And then when the tank is filled all the way, we're going to turn them off at the same time. So the amount of time that each pipe is working is the same. Okay? So what does that mean? It means that T1 and T2 in this case are going to be the same. So we can say that T1 is equal to T2, which is equal to T. Okay? And so I'm going to rewrite this and I'm going to say R1 times T plus R2 times T is equal to 1. And so now what I can do is I can fill in the rates. Okay, so I know the rates, so this is going to be 1/6 times T plus 1/8 times T is equal to 1. And so now I have an equation that I can solve. Okay, now in this case here, I can factor out the t's, right? I can use the distributive property in reverse, and I can factor out the t's. Okay? And then add the fractions and go on, right? And I can get a common denominator, I can add the fractions and do that. So I can do that, right? But let's do it a different way. Let's multiply through by the least common multiple. Okay, let's get rid of the fractions. So what's the least common multiple of 6 and 8, right? The smallest number that is a multiple of 6 and a multiple of 8. Now 8 is the larger number, so again, we probably want to use that as our controlling number. So 8 is obviously not a multiple of 6. So then we go to 16. Is 16 a multiple of 6? No. Is 24 a multiple of 6? Yes. So the least common multiple is going to be 24. Okay, so now multiply everything by 24. So 24 times the 6, right? So that's going to be 24 over 6t plus 24 over 8t equals 24. So all I did was multiply through by 24. Okay? Now I'm going to reduce this. I'm going to simplify this. 24 divided by 6 is 8, or excuse me, I'm sorry, 4. 4t. 24 divided by 8 is 3. And then t equals 24. Okay? So now all I have to do is add or combine like terms, right? So guess what? What do we get? We get our answer, which is going to be 7t equals 24. Then we're going to divide both sides by 7. And we get t, the total time, right? This is the total time that they're working together to fill the tank, is going to be 24/7, okay? Which is going to be 3 3 3/7. And what's this? This is in hours. How do we know this is in hours? Again, look at your unit analysis again here. So what do we got? We've got rate, which is the amount of the tank per hour, or excuse me, I'm sorry, this is in minutes. I erased it, but it's in minutes. So this is, so this is in minutes. Sorry. Okay, so this is the amount of the tank that's filled per hour, or excuse me, I keep saying hour, per minute, times minutes, right? So this is going to equal what? The amount of the tank that's filled. This is going to be the rate for the second pipe, which is going to be, again, the amount of the tank per minute, and then times time, which is minutes. So the minutes are going to cancel in this case. So now in this case here, again, we've got here one tank, right? So in this case here, we do want minutes, and that's what we're going to end up getting, because we end up with the amount of the tank. We've got one tank here, okay? And then this is also, these rates are tanks per minute. So when we do the unit analysis, what are we going to get? We're going to get T equals the amount of the doors, right? Doors, right? So I'm just going to put the units. Doors divided by the rate, which is what? Doors per minute. Which, again, if we change this to a multiplication problem where we're going to multiply it by the reciprocal of the bottom, we're going to get doors over 1 times minutes over doors, right? The amount of, or not doors, I keep going back to the other problem, I'm sorry. Tank. Tank, right? Tanks. How many tanks we're filling up? Tank and tank. And so this becomes tank and then tank. And then these units cancel, and I end up with minutes, which is exactly what I want, okay? So again, always when you check the formula, if you're unsure about your formula, just do your unit analysis and just make sure that all of the units cancel and you end up with the units you expect to get based on the question that they want you to answer, okay? And that's it. Have a great day.